Hi, Dr. M, chemistry tutor here. And in this lesson, what I'm going to do is look at how we can use the Chemcards to help us to work out the formula of ionic compounds and to understand why the formula are the way the formula are. So the first thing you'll need to do is to get your Chemcards out and lay them out in front of you. So I'm hoping you have this worksheet where we're using the formula directly. And if you pause the video for a moment and get all your cards laid out in front of you, and then continue when you're ready to go on with the exercise. Okay, so now that we've got our cards out in front of us, I'm going to have a look at worked example 1 and 2 that you have on the worksheet, and to show how we can use them to find this formula. So the first example that we're looking for is sodium chloride. So ionic compounds are made of metal and non-metal ions bonded together. The blue ones are representing metal ions, the green ones non-metal ions. So we're going to look for, first of all, the metal ion, which in this case is sodium. So we can see that that's this card here. So I'm going to bring that down. The non-metal ion we're after is chloride. So I'm going to have a look through here. I can see it here and draw that together to start to make this compound. Now, the next thing we have to do is to consider the charges on the ions. It's not as straightforward as one of each. We have to look at how the compound bonds together. So if we look at the charge on sodium, we can see it has a plus here. If there's no number with it in chemistry, that means there's one of them. So what I'm going to do is put underneath this what the charge is on that ion. So that's 1 plus, and I'm going to put the number in because ultimately we're going to count these up. Okay, so let's just move that up there. So if we do likewise with the chloride and look at the charge on it, we can see that that has got a minus charge or a 1 minus charge. So we do the same thing again, add those up, bearing in mind that if there's no number there, it means there's 1. So we have 1 minus charge here. Now, the thing about this, sodium chloride is table salt. And when we pick up some table salt, we don't get an electric shock with it. So what that tells us, the fact that we don't get an electric shock, is that this isn't charged up. The overall balance of the charges, if you like, is neutral. So with the ions in the compound, we have to make sure that that is the case. And you see here that with sodium, we've got 1 plus charge here and a 1 minus charge here. These are both the same. So the same number of positives, the same number of negatives. We've got 1 of each there. So we can say that the formula here is one sodium and 1 chloride. So the formula of sodium chloride is NaCl, 1 of each. So let's have a look at worked example 2. The compound we're interested in here is calcium bromide. So again, the first one being the metal from the light blue cards, and the second one being the non-metal from the green cards. So the first one we're looking for is calcium, which we see is here. So I'm going to drag that and bring that over here. And the non-metal we're after is bromide, which we see is this card here. So I'm going to bring that down next to it. And again, at this point, we're going to count the charges. So if you look at calcium, the calcium ion has got 2 positive charges. So I'm going to add up the positive charges there, or just take a note of them, and see that we've got 2 positive charges with calcium. So that's important to see that. Doing a similar thing with the bromide ion, we can see that it has a negative charge. Again, no number means there's 1 of them. So I'm going to write down, as we did before, the charge on the bromide ion, which is 1 minus. And now when we put the positive and negative charges together, we can see that these are not the same. we need to have these balanced in the whole compound, because the compound is electrically neutral. So we've got an imbalance of charges here, so we have to address that. And the way to do that is to see that we're short of negative charges here, so we need to get another negative charge in here. So the way we do that, if you go to your Chemcards and go and get another bromide, here I'm going to copy and paste another bromide card, hopefully. There it is. Let's bring this little box out of the way. Okay, so now if I look at the total charges from the bromide, although each of those has got one negative charge, the fact that I've got 2 cards or 2 bromides means that my overall charge at this point is 2 minus. And in this way, I have balanced the 2 plus charges from the calcium. So what it leaves me now to do is to write the formula. And the formula tells us how many of each ion are present in the compound. So basically, how many do we need to balance out the charges? So we can see here that we have got 1 calcium. So I use a chemical symbol, and the next ion is the bromide. But in this case, we've got 2 of them. So in terms of the formula, we write that as a little subscript, so smaller and down to the right hand side. So the formula of calcium bromide is CaBr2. It means we need 2 bromides to cancel out 1 calcium. So at this point, what I suggest you do is pause the video, use the Chemcards to work out the rest of the formula, come back in a little while and I'll put them on the board so that you can check. Okay, go for it. Okay, so welcome back. I'm going to write the formula besides the names of the compound so that you can check your answers as we go. So magnesium oxide is MgO, so Mg is 2 plus, O is 2 minus, they balance. Potassium bromide is KBr, again, potassium is 1 plus, bromide is 1 minus, so they balance. Sodium oxide is when we start getting into having to make the cards balance. So we need 2 bromines, sorry, 2 sodiums for every oxygen. Sodium is 1 plus, oxygen is 2 minus. Copper sulfate, in this case, we have the copper 2 ion. So, and sulfate is 2 minus. So the formula for that is CuSO4. Sodium nitrate is NaNO3. So 1 plus for sodium, 1 minus for nitrate. So zinc chloride. Zinc is 2 plus. So there'll be 1 of those, but it will need 2 chlorides because chloride is 1 minus. Potassium nitride, so these ones starting to get a bit tricky now. Potassium nitride, you will need 3 of those because those are 1 plus to balance with 1 nitride because nitride is 3 minus. So potassium nitride is K3N. Calcium nitrate, so calcium is 2 plus. Nitrate is 1 minus. So you will have found that you need 2 nitrates to cancel out that Ca2 plus. So notice how we're writing that in the formula, we're putting the nitrate in brackets. So let's look at number 9, iron chloride. So iron is 3 plus and chloride is 1 minus. So you will need 3 chlorides to cancel out 1 of the ions. If we now look at number 10, aluminium oxide. Aluminium is also 3 plus. So if we have 2 of those, that will give us a total of 6 plus. Oxide is 2 minus, and if we have 3 of those, that will give us 6 minus. So we're kind of looking for the lowest common denominator in the way between 2 and 3, which is 6, to give us the formula of aluminium oxide. So I hope you got all those right. And if you didn't get them right, to understand why you didn't get them right, so that maybe you can make that progress in the future. So having a look at section B, if you haven't done already, pause the video and have a go. Just choose 3 other pairings, a blue and a green card, to work out the formula for and the name of some more ionic compounds that are not on the list. And you can get your teacher to check those for you to make sure that you've done them correctly. Okay, good luck, and I'll see you next time for the next lesson.